You've just witnessed flame synthesis of carbon nanotubes. So what are carbon nanotubes? Carbon nanotubes are a pure form of carbon. Carbon comes in 3 different varieties in its pure form. Graphite, like in pencil lead, graphene, which is sheets of carbon, and diamond, which everyone knows is a girl's best friend. But a small percentage of this lamp black is carbon nanotubes. Very simple way to produce carbon nanotubes. Can't get them very pure, but you can get them from here. This is a piece of chicken wire that represents an idealization of a graphene sheet. Each point in the weave represents a carbon atom. The different forms of carbon nanotubes are made by rolling a graphene sheet in different orders, either long ways or sideways. Forms are the chair formation. So, without that piece of support wire, what you see here looks like an armchair. If you can imagine looking straight at an armchair, this is where your armrests are. This is where the seat is. That's the armchair configuration, and that is the most electronically active or conductive. Zigzag conformation of the nanotubes. You can see that the point each carbon atom is on top here, so you get a zigzag effect. Graphene sheet. It's a representation in chicken wire, of course. If we roll it this way once, where they all match up, you can see at this end where we have a zigzag conformation instead of the armchair conformation. And we continue to roll, and what we have here is a representation of a multi-walled carbon nanotube. Carbon nanotubes have been used down throughout history without us even knowing. The highly sought after Damascus blades of the Muslim defenders, the so-called Holy Land, during the Crusade were made from Damascus steel, which has been found recently to have carbon nanotubes in them. The trade secrets for making these blades were lost in the 18th century. We also find carbon nanotubes these days in very unexpected places like mascara, women's makeup. It's also found in parts for the Hubble Space Telescope and for other electronic devices. There are 3 common ways to produce carbon nanotubes. The first and oldest is arc discharge, such as when a welder welds metal together. High voltage creates a plasma, and there is voltage current arcing the gap between the welder and the welding surface. The second way, chemical vapor deposition, uses chemical reactions, heat, vacuum, temperature variables to vaporize the carbon and deposit the carbon on a substrate and build up carbon nanotubes from the base up. And the third oldest way is flame synthesis, which you saw at the beginning of the video. This is a jar of single-walled carbon nanotubes. How much do you suppose this weighs? This is 1 gram. This covers the surface area equivalent to 10 times the floor area of the average 3-bedroom American house. Right here. Applications of carbon nanotubes owe to its ultra-high strength. The carbon nanotubes impart this strength to composites like the sword, and also to futuristic composites like the space elevator that we're trying to build. It also has exciting electrical properties, such as its semiconductor nature, due to how the graphene sheets are rolled, like we showed you earlier with the chicken wire. It gives you a semiconductor or a full conductor. There are also life science applications where you can sequester drugs inside the carbon nanotubes and use them for targeted delivery to cells.